So when designing AI strategy, agentic AI is on the top of everybody's mind right now. But the reality is that most companies don't understand how these systems are working, and so they create a bunch of demos that are unable to scale and don't provide any business value. And so in this video, I'm going to break down the core foundations of agentic AI that every AI business leader needs to know to ensure that their products are going to go successfully. And along the way, I'm going to highlight real-world issues that I've essentially encountered. Now, this will be more tailored towards enterprise-level deployments, but it's still applicable to medium and small businesses as well. Now, to understand how to deploy these systems effectively, we need to really look at the three flavors of agentic AI right now. First is AI workflows, the second is AI agents, and lastly, multi-agent systems. And each one of these has its own technical complexities, but also business trade-offs that we need to be aware of. The first AI decision that most companies start with is AI workflows. And this is where you manually define when the process is going to use an LLM call or a tool call or some other function throughout a predefined process. And this process is pretty straightforward. You essentially take an existing business process and you break it down in its predefined steps. Now, it seems naive, but this is actually something that you should be doing, especially if the process is static, repeatable, and you need high reliability. Now, the main drawback is obviously they're brittle, right? If any step changes, you need to change the whole entire process. And so this is why when you're looking to build AI workflows, the process needs to be a little bit more robust. But what happens when the process is not predictable, right? You can't predict every single step. And this is where most organizations realize we need AI agents. Now, AI agents is when the LLM dynamically identifies how to solve a problem, utilizing tools, utilizing additional LLM calls to actually solve a more complex task. And I'll show you just a quick little example of how these actually work. The most simplest agent is the React framework, reason in action. The agent first has a thought, then it takes an action, then it observes the result of that action, then it loops until the problem is resolved or it hits a final step count. And let's use a common enterprise example here. I have two vendors, Acme and Globex. What is the combined outstanding invoice amount right now? The question comes in. The LLM will first think I should fetch each vendor's outstanding balance and then add them. It will then tool call to an action, the balance, observe that result of $42,500. It will then have another thought. I've obtained the first vendors, now I need to get the second. The next tool call asking for the balance of the second one, observing that balance again at 31,000. Now add the two balances to get the combined outstanding amount. Another action with the tool calling, we call the calculator action. The combined outstanding invoice amount for Acme and Globex is $73,700. Now, this is a simple showcase of how agents are working. Production agents include more advanced pieces. Planning, for instance, there are plan execute patterns that are common throughout enterprise architecture. There's also memory systems like short and long. We'll get to that later in the video. And there's also different ways that the agent can perceive the environment as well. Now that we understand how they work, what are the business implications of this? See, the biggest business piece is trade-offs in accuracy versus reliability. As you saw here, agents are powerful. They'll be able to dynamically figure out how to solve tasks. But that same flexibility introduces inconsistencies. And this is why you always get the question from leaders and also end users, how can I trust this? Is it reliable? For mission critical and regulated industries, especially when I work with government clients, I really err more on the side of workflows rather than agents. See, putting an AI agent here might create unnecessary risk and unpredictability that you may not need. But in practice, most enterprise deployments are not AI agents or AI workflows. It's really more somewhere in the middle. And this is where we think about agentic systems, where these flexible agents and these full workflows are actually more combined and intertwined rather than one or the other. Besides reliability, what are some common issues that we should also be aware of? The first one is memory mismanagement. So as the task length increases, the context is going to increase as well. You've probably personally seen with ChatGPT, when your thread gets very, very long, it's just going to forget things and not understand. Agents are going to do the same thing, and this is where you have to go into advanced strategies of short-term versus long-term memory, and that's more on the engineering side for your engineering teams. Now, on the business side and also on the engineering side as well, one issue that I see a lot, especially with companies that are first building AI agents and then starting to scale them, is the one big brain bottleneck. See, many organizations usually start with one agent and add on capabilities over time. And it gets to a point where one agent is doing everything, all tasks. And you'll see it demos very well, but as you scale it up, it may not perform as well. And then also too, if you do add on new tasks, it might affect the performance of your existing tasks. And so that's when you realize you can't have one agent do everything. This is where we move on to multi-agent architectures. Now, multi-agent systems, this is where you have multiple different agents that are specialized in individual domains or tasks. Now, a core design challenge in any multi-agent architecture is how the agents are going to communicate with each other. And there are two common approaches for this. One is agents share a common state. So there's shared memory, maybe there's a shared artifact list, maybe they're sending messages directly to each other and that's the state. In other architectures, one agent can call another agent as a tool call. So as we did tool calling earlier, you could call an agent directly. Communication patterns are really more driven by the multi-agent architecture itself. Now, this is an overview, but there are multiple different architectures that you can utilize, and each have its own business trade-offs and implementation trade-offs that you'll need to think through with your team. And obviously, choosing the right one depends on your organization's scale, the risk tolerance, maybe governance, and things of that nature. But let's be a little bit more explicit. How do these multi-agent systems actually provide value to our business? One, like I mentioned before, is increased performance. Now that you have multiple agents specializing in a domain, you can expect higher performance, especially if they're communicating with each other. Now, second is faster launches. As you can see, each agent is essentially modular, and so now you can develop and test these in parallel. And this is extremely important, especially if you have a CEO or maybe a manager that's really pushing AI heavily. This will help you get faster implementations more quicker. Last is cost efficiency. Especially since there's multiple agents, you can actually right-size the model for each specific task. Now, what are some common issues that we see when implementing multi-agent systems? Now, from the engineering side, a lot of it is really just coordination. And this is making sure agents have clear roles, clear protocols, that shared understanding to allow them to really work towards more complicated business problems. But on the business side, the biggest thing here is cost control and also performance. As you can see, AI usage is going to skyrocket in these multi-agent systems. This is where you need to ensure monitoring frameworks are in place ahead of time. For those who watched my previous video, this is where the model gateway becomes very important. Now you can use smaller, cheaper models for individual tasks. Lastly here, I'd recommend setting things like budgets, definitely alerts so that human operators can take over if needed, and also any process level controls. Sometimes there's runaway processes that human operators need to shut down, or it can just budget it and be stopped automatically. Now, as you see, agentic AI systems is really about balancing autonomy, reliability, costs. One aspect that I didn't get to cover in this video is risks. Because as you know, identifying risks early, not just on the project level, but also on the strategy and implementation level across your organization is extremely important. And so in my next video, we're going to go through common risks of agentic AI systems, and then also how to mitigate some of these issues to ensure that our long-term AI strategy and our projects are still in line. So anyways, thank you so much, and I'll see you in the next one.